You might have tried this question and you find out that you could not solve it. Why is that? It's not that you are not good enough, but the problem is that this is a very, very tricky transcendental equation. Okay, transcendental equations are equations that we can't just solve with ordinary algebraic methods or exponential method. This specifically is an Olympiad problem, not just an exercise. This is not an exercise, it is a problem. Okay, it's an Olympiad competition question. So you have to rack your brain. Now, how are we going to do this? One of the ways you can do this is by recognizing a pattern. That's why it is Olympiad. You have to recognize a what? Pattern. Now, in place of recognizing a pattern, I'm going to like us to employ a method, a fancy method, okay, that I call unifix. Okay, just a fancy word by me. So what is unifix? Unifix is just a way of unifying variables, okay, fixing variables. When we look at the variable of x now, right, they are not unified. This variable of x is in a different form and a different shape from the variables of x here. So I have to employ unifix and make them look exactly the same. Okay, they are very different. Here, there's x out, there's not x out here, there's 2 here, there's not 2 here, and all that. So we have to unify these two variables, make them look exactly the same. So in order to do that, we have to recognize a pattern. Like I've said before, what pattern? Now, if we're familiar with alpha beta expansion, okay, by looking at this here, I can sense something like alpha. I can sense something like alpha squared yes plus minus 2 alpha beta. I can sense it from this question here. What am I saying? When you look at this here now, alpha squared will give us x. That's root x squared give us x. Then minus 2 alpha beta. 2 times alpha times beta. Can you see? Now I have gotten an idea of how I can get this from this. As simple as that. Recognize a pattern. So what am I trying to say is that, in case you are still confused, what I'm saying is that we can actually get this by squaring this, okay? If we square root x, for example, let me do it here. This one is meant for the solution. Let me come here. So let's say that we square root x minus 1 for an example. When we square this, that will give us alpha squared plus beta squared minus 2 alpha beta. So that will give us x, this one squared will give us x, then plus 1, then minus 2 times 1 times root x will give us this. So it means that this actually will give us minus 2 root x plus 1. Voila, something we have recognized. Yes, can you see? We have actually extracted this from this. That is the pattern that we need. It means that if I square this here, I will actually get something like this from it, so that the variables of x can be finally unified. That's the idea there. In case you don't know alpha beta, please, when you expand this, multiply the bracket twice, you're going to get this. Now, that's very, very nice. So what that means is that I have to square this, okay, so as to make them unified. And how do I square this? Mathematically, please. And how do we do that mathematically? We square both sides. What I'm saying is that we'll square this and we'll square this. So we're going to have, when we square both sides, we're going to have square root of x minus 1 all squared, right? Then a times 2x minus 2 root x equals 1 squared. Okay, what did I do here? It's very, very simple. If we square this, don't forget law of indices, the square will be shared to the two of them. Okay, this will take one square, this will take another square, law of indices. Then this one will take a square. Then when this one takes a square, don't forget the square multiplies this power, law of indices. That's why we have this 2 here. So just have to make it a little bit faster. Now, so as I've squared this here now, I can now use the substitution. This squared will give me everything here. So let me write that here. So instead of this now, I'll be having x minus 2 root x plus 1. Then to the power of 2x minus 2 root x, close the bracket. 1 squared will give us 1. Okay, now we are getting very, very what? Close. Okay, we can see now that these two variables are now what? Unified. Now can I use a substitution? Instead of this, we can now say let x minus 2 root x, let's say equals u for an example, okay? Because now they are unified, they have exact same word form. So now we're going to have u plus 1 e raised to the power 2 u. Can you see that? We have broken this down to this. Very, very nice. Equals to 1. Please don't let me forget. Equals to what? 1. Now, very, very easy for us to continue with unifix because we now have u and we have what? U. When we're done with unifix, we have to make them look exactly the same. Now, what is the difference? Here has a 2. It has a coefficient of 2, but here does not have a coefficient of 2. That means u here must have the coefficient of what? A coefficient of 2 for them to be exactly the same way. How do we do that mathematically? Very simple. Multiply both sides by 2. So we have 2u plus 1 e raised to power 2u equals to 2 times 1 will give us what? 2. Then we expand the bracket. So we have 2u plus 2 a to the power of 2u equals to what? 2. Now we are getting very, very close. They are almost the same. We have 2u, we have 2u. Now something is missing. This one has an added term of 2. Okay, sorry, there's 2 added to it. Why this one does not have a added what? An added 2. So what we're going to do is that we have to introduce 2 plus 2 to this power. How can we do that again mathematically, please? Very simple. We just multiply both sides by e to the power of what? 2. Multiply both sides by e to the power of 2. So we have e. Okay, let us post multiply, not pre-multiply, post multiply. No difference. That's 2u plus 2 e raised to the power 2u, then times e squared. That'll give us 2 times e squared. Yes, the reason why we multiply both sides by this is because when we use law of indices, these two powers will be what? Added. So we have 2u plus 2. Now let's continue here. We're going to have these two power according to law of indices. So we have 2u plus u, then 2u plus u. We'll pick one e, then 2u plus u equals 2e to the power of what? 2. You can put a bracket here. It doesn't change anything. Now we have successfully used unifix to unify the variable. Now it's not very, very easy to solve. I'm sure many of us can solve it by ourselves from this place. Okay. Now we can use Lambert omega function to get this answer directly, but we don't have to use Lambert omega function. Okay, it will be like an overkill. Now by easy comparison, we can actually get the value of what? U, because this e to the power of this, 2e to the power of this, they're exactly the same. So we can just use equation. Therefore, 2u plus 2 must be equals to, okay, so we solve for u from here. Now, we will now have 2 comes here, 2 minus 2 gives us 0. So we have 2u equals 0. When we divide both sides by 2, we're going to have u equals to what? 0. Okay, now u equals 0. We don't need u. Okay, we don't need u. We actually need what? What is our substitution? X minus 2 root x. So we can substitute that into this. So instead of u, we have x minus 2 root x equals to what? 0. Now we can now solve this equation by ourselves. Very, very simple. So how do we solve this? I'll prefer we factorize square root of x out. So when we factor out square root of x, we have square root of x minus 2 equals 0. When you expand the bracket, you still get the same things. This time, this will give us this. Or you can do the normal conventional way of taking this one to the other side, squaring both sides, and solving the quadratic equation. We still arrive at the same answer, but this one is just quite faster. Okay. So by equating, we have square root of x equals 0, or square root of x minus 2 equals 0. Can you see? Then we'll now solve for x from here. Therefore, when we square both sides, x equals 0. Or when we transpose this, we have 2. Square both sides, we have 4. So x will be equals to what? 4. Okay. Now we have two answers. But this 0 will not be part of our solution, because if we substitute 0 into this equation, we're not going to have 1. Now when we substitute 0 here now, 0 minus 1 will give us negative 1. And we have 1. The negative 1 cannot be equal to 1. Therefore, this is not a solution. Okay? So therefore, finally, x will be equal to as simple as ABC. Now, this is one of the solutions to this question, this tricky question on the board. Please don't forget to subscribe if you have learned something from this video. Okay? Till next time. Bye-bye.